Hello everyone. In the previous video, we have learnt about the empirical approach or empirical formula of finding the probability of an event. In this video, we are going to learn about the classical approach to the probability and also the classical formula of finding the probability of an event. What is classical approach? Actually, if we have any of the experiment in which we find there are n equally likely events, then to find out the probability of any of the event is known as the classical approach. And the classical formula is given as, suppose there is a particular event A. Then we find how many of the events are in favor to that particular event, and then the probability of A is defined as the number of favorable events to A divided by the total number of equally likely events. So we have to understand the difference that in the empirical approach or empirical formula, we were finding the probability of any event as the ratio of the number of times the event occurs divided by the total number of trials of the experiment. But here, this is the experiment maybe once or maybe repeated, and then we have to find out the number of favorable events to the particular event A, and the ratio of it to the total number of equally likely events is the probability of A. Suppose there are m events which are in favor to the event A, then the probability of A will be defined as PA equal to m upon n. This approach or the definition is also known as the priori definition of probability. Why? Because the event A is defined on the basis of the prior knowledge. See, the probability of A we have seen is m upon n. And we know that m has to be less than or equal to n. And it is a positive number, so it is greater than or equal to 0. It means the probability of A will be from 0 to 1. And we have also learnt in the previous video that probability of any event is 0 if it is an impossible event. And probability is 1 if it is a certain event or a sure event. Now, what is the probability of a complementary event? We know complementary event is when A does not happen. So that is also known as probability of not A. Now, the favorable event to A are m. It means the probability of not A, which is also represented as PA dash, or we can write this as PA bar, and this probability PA dash can be written as number of events not in favor to A divided by total number of equally likely events. When m is in favor to A, certainly n minus m will be not in favor to A. It means when A does not happen, divided by n. Can we write this as 1 minus m upon n? And we have seen m upon n is PA. So can we write this is 1 minus PA or not? And this implies that PA plus PA dash is equal to 1. So we can say that the complementary event is the event when the event A does not happen or not A. And the probability of that will be equal to 1 minus the probability of happening of A. And also we find that sum of the probability of any event A and the probability of its complementary event will be having a sum of 1. Now, what are the limitations of classical approach or classical probability or classical formula? There are certain limitations, like we have the number of events should be definite. Number two, we can say the events are to be equally likely only. For other events, this may not be applicable. And the third limitation here comes is that this is used in limited fields only, like tossing a coin, rolling dice, or playing cards, etc. We are selecting a card from the deck of cards. It means we have to make the assumptions before the experiment is performed. Now we will discuss some of the examples based on that. See, the first one here is a coin is tossed twice. What is the probability of getting number one, 2 heads, and number two, at least 1 head? For the solution of this, what we see, first of all, we have to see the sample space when we toss a coin twice. The sample space S here will be either both head or 1 head, 1 tail, or both the tails. It means the number of total events here is 4 and all are equally likely. Number of equally likely events is equal to 4. That is an. Now, when we go to the first case, we have to find out 2 heads. Suppose this is the event E. Then what is the number of events in favor to A? We are finding that is only 1 H. This is equal to 1. So what is the probability? Therefore, probability of A will be, according to the definition of probability, it will be m upon n, or we can say 1 upon 4. In the second case, we have to find out at least 1 head. At least 1 head means either 1 head or 2 heads. And what are the events? The events we are finding here, suppose this event is B, those events are H, both the heads, or 1 head. Are we finding there are 3 events which are in favor to B? Number of events in favor to B, that is equal to 3. So what we say, probability of B here will be, according to the definition, 3 upon 4. This is the way we can make use of the classical formula of the probability and find the solution of such problems. The next example we discuss here is a pair of dice is rolled once. What is the probability of getting a sum of 8? For the solution of this, what we see, first of all, we will write the sample space on rolling a pair of die. Pair of die means there will be 2 numbers always, 1 on each die. That is like 1 1, 1 2, 1 3, and so on. It will go up to 1 6. Then we start with 2 1, 2 2, and it goes up to 2 6. And so on, all the numbers we are getting up to 6 6. How many are these? The number of total events in this will be 6 into 6, that is 36. We have to learn it in case we are performing 2 of the experiments together. Then the total number of events in the sample space will be equal to the number of the events of both multiplied. Like here it is 6 into 6. Suppose we are rolling a die and tossing a coin. Then the total number of events in that will be 6 into 2. That is 12. 6 is the number of events on rolling a die and 2 is the primary events on tossing a coin. That we have to remember. So here it is 36 events in total and all are having equal chances. It means they are all equally likely. Then which are the events out of them having a sum of 8? If we consider getting a sum of 8 is the event A, let A be the event of a sum as 8. Then the events which are in favor to A or the events which are favorable to A, events favorable to A will be what? Having a sum of 8. That may be 6, 2, 5, 3, 4, 4, 3, 5 and 2, 6. These are the only events which are for having a sum 8. What is the number of them? Suppose this we consider as n, then we say n is equal to what? n is 1, 2, 3, 4, 5. Number of favorable events is 5. Then the probability of A, probability of getting 8 will be number of events favorable to A divided by total number of equally likely events. So here it will be m upon n, that is 5 upon 36. This is the probability of getting a sum of 8. Next problem we will discuss here is, from a well shuffled deck of cards, a card is drawn. What is the probability that it is a king or an ace? First we have to know how many cards are there in a deck. There are 52 cards. So we write total number of cards is equal to 52. How many are the kings? Kings are 4. Number of kings is equal to 4. And how many are the aces? That also is 4. So we can write number of aces is equal to 4. It means any one of these 8 cards, one card should come. So we can write, therefore, total number of favorable events is equal to 4 plus 4, that is 8. This can be considered as n and this is m. And what is the probability then? Therefore, probability of an ace or king, that is suppose PA, will be equal to m upon n. M is 8, n is 52. If we cancel by 4, 4 to the 8, 4 is 13, this is 2 upon 13, this is the answer. So in this video we have understood now what is the classical approach and classical formula of finding the probability. In the next video we will be learning about the odds. What is the meaning of odds in probability? That is, what is odds in favor and what is odds against, and how to apply them in finding the probability. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.